And so we can then say, okay, let's do the second expansion. And let's set P external equal to P2. And we do the same sort of thing. We have stops here. We have P1, V1. And we don't really need stops up here. We have a weight on the piston. And that weight is chosen so that it acts as though P external is equal to P2. We know the pressure is equal to force per area. And so we know the force for a particular mass, and we know the area of the piston. So we know how to do this. And we know this thing, when it hit these stops, the pressure was P2 and the volume was V2. Now we could put stops here at V2, but this piston would just kiss the stops. It would stop there because we've chosen P2. The work for that process is going to be minus V1, V2, P2, because that's what we chose P external to be, dV. And that's going to be minus P2, V2 minus V1. That's the work. V2 is larger than V1, and so this quantity here is positive, and we have a negative sign because the system did work. So now we can take the result from this and put it onto a PV diagram. P1, P2, V1, V2. So here is the initial situation, and here is the final situation. And the equation of state, pressure versus volume at constant temperature, is going to have some form, and let's just draw it in there like that. So that's an equation of state. It's like the ideal gas law, and one could know that in principle. Okay. So we did work. Oh, I should mention, P times V has units of energy or units of work. Remember that, because you're going to find lots of thermodynamic quantities, and you're often going to be writing on deriving things on exams, and you're going to almost always want the combinations of quantities to have units of energy. So dimensional analysis is extremely valuable in thermodynamics, and here is an example of it. Anyway, the work associated with process number 2 is described by this box, because we did work at constant pressure, and so it's just volume difference times pressure. Okay. Now we can do the process in 2 steps. So we start out with our piston. We have 2 weights on it. So we have P1, V1. We have stops. We've chosen 2 weights so that this is P3. External pressure is P3. It's higher than P2. So we remove the stops, and the piston moves up. And now we remove one of these weights. And when we remove one of the weights, this gives an external pressure P2. So the piston moves up again, 1 weight. So here is P2, P external, here is P3. And so we have the work coming from 2 steps. And it's trivial to calculate what that will be. And when you do that, we put P3 in on this diagram. What you end up finding is that you get an initial little bit of work corresponding to V3. So we break up our work into two pieces, and we get more work out.